Solving quadratic equations using the quadratic formula. Your standards are listed, as always, and your success criteria. To be successful, you need to be able to solve a quadratic equation using the quadratic formula, find and interpret the discriminant of an equation, choose an effective method for solving a quadratic equation, and explain my choice of method. Here's your vocabulary for the lesson. Quadratic formula gives the solutions of any quadratic equation in standard form. Remember standard form, ax squared plus bx plus c equals 0. Sometimes you will see y equals ax squared plus bx plus c as well. All right, the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A, again, cannot be 0 when you're talking about a quadratic because you can't have a 0 x squared, or there is no x squared, and that's what makes it quadratic, is the x squared term. And b squared minus 4ac has to be greater than or equal to 0. So what is b squared minus 4ac? This is known as the discriminant. All right, the discriminant tells you some very valuable information. So it is part of the quadratic formula. Here's your key ideas that you need to commit to memory. When your discriminant, b squared minus 4ac, is greater than 0, meaning it's positive, you're going to have 2x intercepts, which leads to 2 real solutions. When your discriminant, b squared minus 4ac, equals 0, that means you have 1 x-intercept or 1 real solution. When your discriminant, b squared minus 4ac, is less than 0, so if your discriminant is negative, you get a negative number under the square root, you're going to have no x-intercepts and no real solutions. Example 1, using the quadratic formula. All right, so we have 2x squared minus 5x plus 3 equals 0. So the first thing we need to do is identify our a is 2, b is negative 5, and c is 3. All right, so you always want to identify your a, b, and c. And this comes from your quadratic term. See, your 2 is your quadratic term, b is your linear term, and c is your constant. It's very important that it's in standard form because, again, quadratic term, linear term, constant term, when it's in standard form, those are very easy. They're going to be right in order. All right, so to solve using the quadratic formula, we're just going to plug in our numbers. So we have negative b, so we're going to have negative 5 because b is negative 5, plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, for example 1, we're going to use the quadratic formula to solve. So we have 2x squared minus 5x plus 3 equals 0. So the first thing we need to do is identify our a, b, and c. So we have a equals 2, b equals negative 5, c equals 3. All right, so remember, if it's in standard form, your quadratic term, anything next to the x squared, that's your quadratic term, that's 2. This is called your linear term, negative 5. This is your constant term. All right, this is very important to know these terms on the EOC. There's always questions about identifying specific parts of an equation, and it seems like that's something that we have struggled on in the past. So make sure you know quadratic term, linear term, constant term. All right, so we have now just to fill into the quadratic formula. So we're going to have negative b, so negative 5 plus or minus the square root of b squared minus 4 times a times c all over 2a. Now we just have to simplify. If you can simplify your math correctly, this should be easy from here. So we've got negative 5 makes that a plus 5 plus or minus negative 5 squared. Again, remember you're squaring b, and b is negative 5. So you're squaring the negative and the 5. So that becomes positive 25. And then minus 4 times 2 is negative 8. Negative 8 times 3 is negative 24. 2 times 2 on the bottom will be 4. And then simplify further. So we have 5 plus or minus. The discriminant under the square root, 25 minus 24, will become square root of 1. And this is over 4. All right. So the square root of 1 is just 1. The square root of 1 is 1. So we simplify that, and then we have x equals 5 plus or minus. So this represents two distinct answers. So we're going to have 5 plus 1 over 4, and we have 5 minus 1 over 4. And so 5 plus 1 is 6, and 5 minus 1 is 4. And so 6 over 4 reduces to 3 halves. So x equals 3 halves is one of our solutions. And 4 divided by 4 equals 1. So x equals 1 is our second solution. All right, so you should be able to plug these x's in. When you plug these in for x, they would equal 0, and that would be an easy way to check to make sure those are your two solutions. You can also graph this quadratic equation and see if the x-intercepts are at 3 halves and at 1. All right, give me just a moment to erase this and we'll do example B. All right, let's look at example B. 4x squared minus 4x equals negative 1. All right, so I'm going to use both sides of the screen again, just because I probably will need this much room to write. So we're going to have 4x squared minus 4x. I need to add the 1 to the other side and set that equal to 0. All right, so now for part B, this is our equation in standard form. So once again, we need to identify our A. Our quadratic term is 4. Our B, our linear term, is negative 4. And C, our constant term, is 1. And then just like before, we're going to plug it into the quadratic formula. So I'm going to have negative 4 and then plus or minus b squared minus 4 times a times c. And all of that is over 2a. A is 4 this time. All right, then simplify further. Negative 4 is plus 4. Plus or minus, again, the negative b gets squared, so negative 4 squared is positive 16. Minus 4 times 4 is negative 16, times 1 is still negative 16. 2 times 4 in the denominator is 8. To simplify further, we're going to have 4 plus or minus 16 minus 16 is 0. So we're going to have the square root of 0. So the square root of 0 is just 0. So we don't have to actually put that, but we will for one step. All right, so then we're going to have x equals 4 plus or minus 0. 0 doesn't change anything. So it's really just going to be 4 over 8. And 4 over 8 reduces to 1/2. Now that's one solution. Hopefully that makes sense, because if you remember, let's scroll back. When your discriminant is equal to 0, here in the middle, when your discriminant is equal to 0, you have one x-intercept and one solution. So as soon as I've seen that the discriminant is 0, that means I'm only going to have one solution. So x equals 1/2 is the answer for part B. All right, please take a couple minutes and try the self-assessment. For A part, you need to do the quadratic formula to find the solutions of this quadratic equation. For B part, explain how the quadratic formula can be used to solve 12x squared minus 7 equals 0. C part, what is the value of b squared when a quadratic equation of the form ax squared plus bx plus c equals 0 has exactly one real solution? We just talked about that. So explain your reasoning. I'll be back in a couple minutes to check your answers. All right, A part has two solutions, x equals 5 and x equals 1. So you would do the same thing as we've done in the previous two examples. Identify A, B, and C, plug it into the quadratic formula, which is right here, and solve. All right, B part, explain how the quadratic formula can be used to solve 12x squared minus 7 equals 0. Since there's no linear term, that means B is 0. So A equals 12, B equals 0, C equals -7. Now it's important that you know that the linear term is 0 and you don't mix up B and C, because if you switch B and C, of course, when you plug those numbers into the formula, you're going to get a completely different answer, which would be incorrect. So once again, you need to make sure you know the quadratic term is the one with the x squared. That's going to be your A. Your linear term goes with the x, and that's your middle term if it's in standard form right here. And then your constant term has no variable. There's no x attached to it. So that's how we know that is your constant term. C part, what is the value of b squared when a quadratic equation of the form ax squared plus bx plus c equals 0 has exactly one solution? All right, so we already talked about that, and if it has exactly one solution, that means the discriminant here equals 0. All right, this looks like this is over top of this, but it's not. All right, so if the discriminant equals 0, what does b squared have to equal? B squared would have to equal it would have to equal 4ac, because b squared minus 4ac equals 0. All right, so what would b squared have to equal? It would have to equal 4ac.